Hello, our most valued student. My name is Confident. Welcome to our revision session. This is Engineering Science N2, and the topic that I just want to quickly look at is the part of chemistry. Now, in chemistry, you find it's a small section in your engineering science, usually worth between 8 and 12 marks or 13 marks, but it is one section. Sometimes you might easily get your marks because most of the questions are usually straightforward. So what I did, I just picked up three different papers, and in those papers there are questions that I just want to focus on. Now look at, it's usually in question, as you can see, it's question number 8, and it is under the particle structure of matter. But as I said, this is the chemistry section and it's in question number 8. So let us look at the few approaches that usually are common in these questions. The first part of this question is the part which says define an element. So now whenever you are defining an element, you can many different definitions here that you can think of, but I'll just give you some common definitions that usually will give you a mark. So this is 2 marks. So an element is a substance. The keyword there is a substance that has the same number, the same type. The key there is the same type of atoms. So whenever they are going to be marking you, they will be marking you the part to say it has the same type of atoms. So in an element, for example, one element that is common, they can sometimes say give us examples of elements. For example, copper is an element as a metal, so it has got the same type of atoms, which is copper atoms. Anything or all the groups in the periodic table, you can have sodium, it is an element. You can have chlorine, it is an element. As I said, it's every substance in the periodic table are called elements. That's why the elements of the periodic table. So anything that you find in the periodic table is an element. Why? Because it contains the same number, the same type. Actually, I keep on saying number, but it's the same type of atoms. So that is an element. The next one, it says that is 8.1. Now 8.2, it says differentiate between atomic number and atomic mass. So how do you differentiate between atomic number and how do you differentiate between an atomic mass? Now, just to give an example, I was giving an example of sodium. You'll discover that in the periodic table, sodium is written as like that with 11 and 23. So now these two numbers, the top number represents the atomic number and the bottom number represents the atomic mass. So what are these? That's why they say here differentiate between. You have to differentiate, meaning you have to show the difference between that and that. So what is it? Now the atomic number in this case, it is the number of protons in an atom. So that is the atomic number. What is the atomic mass? It is the number of protons, and that's where the key thing now, the difference, and neutrons in an atom. So that is the part to say whenever you're looking now at the atomic number, you are looking at the number of protons and neutrons. But when you're looking at the atomic mass, but when you're looking at the atomic number, you are just focusing on the protons. So in here you can see that if the atomic number here on this sodium atom is 11, now what about the neutrons? The neutrons will be 12, so that when you add 11 plus 12 you get 23. Remember we said if you add that, you're going to get 23 because the atomic mass is the number of protons and neutrons in an atom. So this is 2 marks, but the key thing there is to differentiate between the protons, which are in the atomic number, and the neutrons, which are in the atomic mass. Now let us look at 8.3. And 8.3, they're saying name 2 examples of compounds. Here we're looking at compounds used in the household. Now they're saying just 2 examples. Now compounds used in the household, this is quite an open question. Now what do we use in the household? The most common 2 compounds that you use, don't think much about this. It's water. Water is a compound because it's H2O, remember. And the most common one also is salt. But now don't just say salt, you must call it, because they need to know the chemical name. It's sodium chloride, which is the proper way of putting it. So say sodium chloride, and then which is NaCl. So that is, these are the common 2 things, the salt that you are using when you are cooking. But now the problem just mentioning the word salt is that there are many types of salts that can be termed salt. That's why you must be specific to say you are dealing with sodium chloride. So those are the common 2, but there are many that you can use. You can say vinegar, you can say acetic acid. This is the one that you find in lemons, because lemons, it's got acetic acid. So there are many different compounds that you can think of, a lot of them. As long as it is something that is a chemical, you can call that a compound that is used in the household. So the common one, as I said in this question, whenever they bring it, think of sodium chloride, which is the salt, table salt, as well as what do you call this, water. Now 8.4, explain clearly when an atom has a positive ion. So here you're talking about an atom that has a positive ion, and when an atom has a negative ion. Again, it's 2 marks. Now for an atom to have a positive ion, for example, if I say sodium plus, you see, this is an ion this is an atom of sodium with a positive charge. This is now an ion of sodium. Now what happens? We are saying explain clearly when. So for it to have that, we are saying it occurs when an atom loses, that's the key word I want there. When an atom loses, or to lose, or donates is another word, or donates an electron or electrons, can be 1 or more. So it occurs when an atom loses or donates an electron or electrons, or it occurs when an atom loses 1 or more electrons. So that is what happens when you get a positive ion. Now what about a negative ion? So when we're talking about a negative ion, sometimes we're referring to something like this. Chlorine is negative, or sometimes you can think of oxygen, or 2 minus. So what happens in this case? You notice this one, that is a negative ion. It occurs, it's the opposite now, when an atom, instead of loses, now it gains. See the difference there? It gains or accepts an electron or electrons. Sometimes it can accept 1 or more electrons. So that is what happens when you get a negative ion. So ions is when an atom accepts or donates. So ions are always formed. When it's positive, it's a donation. When it's negative, it's when it accepts an extra atom or atoms. So that is the part, as I was saying, question 8. Let us move on to look at another question again. So these are just theory, simple theory or simple explanations in chemistry that you can use, as I say, to take advantage of that. Now look at question 8 again. It's different paper. It's the particle structure of matter, mainly chemistry. And question number 8, 8.1, it says here, define an electrolyte. So if we're looking at 8.1 and we're defining an electrolyte, I think from the term you can see it's more like two words, electricity and then there is the light part from electrolyte. So what are these? We are saying an electrolyte, it is a substance, a chemical substance that conducts electricity, that conducts electrical current. Electrical is a substance that conducts electrical current. Or sometimes we can say it is a substance that allows, it's a substance, it's 2 marks, that allows ions, it can be positive or negative, to move or to flow. It allows ions to flow. It's a substance that allows charges to be transferred. So by charges you are referring to electrons, ions, anything that is charged. So an electrolyte will allow those charges to be transferred from one place to another. So that is the first part. Now let us look at 8.2. 8.2 says give 2 practical uses of electrolytes. So when do we use the electrolyte? So you find the common uses of electrolytes. The common one is electroplating. When you do electroplating, it's common when you use this. You can find in the chemical industry, electrolytes, chemical industry, in manufacture of chemicals, in manufacture of chemicals, can be different chemicals. When can you use electrolytes? You find electrolytes like in manufacture of batteries. Remember, they just said example here. You can use it in manufacture of batteries, which is common because it deals with electrolytes. Batteries, I just wanted to say battery, just anything that comes in mind. Electrolytes, you can find it even in purifying of metals, for example. In the metal industry you can find this is common. What else? You can find in, we said electroplating, you can find in these are the common ones. Just they need 2 marks, so I think that's sufficient. That is 8.2. Let us look at question 8.3. And question 8.3 says give 2 uses of electroplating. So you see now they are referring to electroplating. Remember we said on the top part to say 2 practical uses of electrolytes. It was in electroplating. Now they want us to give 2 uses of electroplating. Where do you find it being used? The first one, you find electroplating being used in coating or protecting is the word I'm looking for. Protecting another metal from corrosion or rusting. So that's when you find electroplating coming in place. There's the spelling there, from corrosion or rust. Remember, whenever you're coating a metal with another metal, so what you're doing is you're protecting it from rust. Where to use electroplating sometimes is for beautifying purposes. That's when you find that a simple steel metal is coated with gold so that you can beautify, for increasing the value of an object, increasing the value of an object. After electroplating, you might find that they are selling it at a higher price, because it has got now a higher value. So that is when you use electroplating. Another part that you can use it is for electroplating, you can use electroplating. I think that also work in forming a hard outer layer on an object. Let's say you want the object to have a hard outer layer which is resistant to maybe rusting, to corrosion, or anything. You can use that electroplating as a way. So that is that part. So just two, but mainly is for beautifying purposes as well as preventing a metal from corrosion. Then we look at the last one, which is 8.4. Name two methods to prevent corrosion. You see that there is the question now. 8.4. How can you prevent corrosion or rusting? Number one, the common one is greasing, by applying grease or oil on a metal or on a surface. You can create that. The common one we started with was electroplating. They asked give two uses. We said for prevention of corrosion, so electroplating. And then the other one, you can use painting. If you paint the surface of a metal, you can actually prevent corrosion. And then the other common one is galvanizing. So these are the common ones that you find. You can grease, you can electroplate, you can paint, you can galvanize. So those are the common ones for prevention of corrosion. Sometimes they'll say, instead of corrosion, they will use the word prevention of rusting. So the answers will still be the same. So let us look at the last part now of this lesson. As I said, I'm still continuing to look at the particle structure of matter, which is mainly chemistry part of it. Now 8.1, it says make a neat label sketch of an atom and clearly indicate the charge of it. And then it's 4 marks. Now for you to be able to ensure that you get all the 4 marks whenever you're making a sketch of an atom, so remember they say it must be neat. So try to make a proper round. If you've got a metal coin, try to use that for a smooth round, or if you have got some compass to draw a smooth round, it will be fine. So what you have is you've got that, and then in the center, in here, in the center, what you have, remember they say make a neat label sketch of an atom and clearly indicate the charges. So the charges are important. You say positive for P, protons, and then you say N for neutrons, and then on the outside you say E. So you can have a scale now to say E represents electrons, and then which is what? Which is negative there. You put a negative sign there to say they are negative. You just want to ensure you get all your marks. And then that P represents protons, and they are positive, and then N represents neutrons, and these, they are neutral. So that is the structure of an atom, whereby you have an electron which has got a shell like that, and then you've got in the center, in the nucleus, the protons and the neutrons. You can even label that as the nucleus. So that's what they mean by that. And then they say the other part, I think 8.2, we've looked at a similar question. 8.2 says define the term electroplating. So they want the definition now of electroplating in 8.2. So now when we are talking about the definition now of electroplating, we're saying it is the process. We're looking at the uses and of that, or the advantages. The process of coating a metal with another thin layer of metal. So that is what we mean by that, by electrolysis. Remember, there was a part which I looked at the part of electrolysis. So in electrolysis, which electroplating uses the method of electrolysis, and in that part you are coating a metal with another layer with a thin layer, not a thick, it's a thin layer of another metal, and then it's just one mark. So if you just say the process of coating a metal with another thin layer of metal, it was also fine. And then state two methods of prevention of corrosion. We've already looked at these to say you can grease, I looked at this in the previous section, or oil. Here you can galvanize. We said you can electroplate, and then we said you can so you can electroplate, you can grease or oil, you can galvanize, you can also another part is these are the main one. You can electroplate, you can grease, you can galvanize, you can paint. That's another one that we said. So that is how you can this is 7 marks. That's how you can simplicate all your marks whenever it comes to this section. As I said, guys, it's chemistry. Usually it's a small part that is ignored, but if you can get more practice on these, the questions are usually the same, and it can guarantee you a good 7, 8 or up to 13 marks in your final exams. I hope this was of benefit to you. Remember to subscribe to our channel, as well as turn on that notification bell so that you can always be notified every time we're posting some new videos. We've come to the end of our lesson. Thank you.